Okay, so for those who joined a little late, I'm Niketa and I'm a PhD PMRF scholar at IIT Madras, and I will be the TA for the course Industrial Wastewater Treatment. And this is our first class, so it will be an intro class. So, and I'll also go through whatever you have seen in the first week's lectures. So, I'm hoping that you all watched the lectures from the first week. So I'll just be going through them. I'll be giving you a brief summary. And I'll be uploading the videos on my YouTube channel. So, and the link will be present. I mean, the link will be given to you in a Google Sheet, so you can go through the videos after this class. If you have any doubts, you can replay them. And in case if you have any doubts after watching the week's lectures, you can also ask me in this doubt clearing session. Okay, so since this is an intro class, so I want to start by getting your names and your introductions. So can we, can you all give me your names and where you're from? Let's go one by one. So who wants to go first?
Yeah, myself I start, ma'am. Ma'am, my name is Ashwin from Coimbatore.
Okay.
I'm working in recirculating aquaculture systems for aquaculture.
Okay. Nice.
Generally, the nitrification system for aquaculture system.
Okay.
Good evening, madam. I'm Vishnu from Pune, Maharashtra. I'm working in as a officer.
Okay. Nice. Hi, Manish.
Good evening, madam. I am Amuda from Naharkoil. Now I am working in private engineering college, madam.
Good evening, madam. I am Raj Kumar from Tamil Nadu, Chennai. I am working in. Hello.
Hi, Raj.
Hi, ma'am. I am working in Paractive Technology in pharma ETP field. I am just now 6 months experience, ma'am.
Okay, nice.
So good evening, team. Good evening, Nikita. Actually, I am from Tamil Nadu. Currently, I'm in Mumbai working in a system in the private limited.
Your name?
Yeah, Franklin. This is Franklin Singh. Yeah, I'm from Tamil Nadu. Actually, currently, I'm in Maharashtra, Mumbai.
I'm working in a system India private limited. It's a water
Actually,
treatment.
Okay, nice.
Good evening, ma'am. My name is Ashwabika from Kururu in studying Aegis Play Engineering College, Nagapattinam, ma'am.
Nice.
Hello, ma'am.
Hello. Yeah. Hi, Sabita.
Hi, ma'am. I'm from Tiruvarur, ma'am.
Okay.
Study Aegis Play Engineering College, Nagapattinam, ma'am.
Okay, nice. Who wants to go next?
Good evening, ma'am.
Good evening.
I'm Parth. I'm basically from Delhi, and I'm having almost 6+ years of experience in the wastewater treatment industry.
Hi.
And since we are from the same field, I'm really looking forward to exchanging our experiences and gaining a lot from this course. Thank you.
Sure. Hi, Amuda.
Hello, madam.
Hi.
Good evening, madam. I'm Amuda from Naharkoil, madam. I was already completed my ME Environmental Engineering. I wish to join this course for knowing this industrial wastewater treatment.
Nice. Others?
Good evening, everyone. I am B. Vijay Raghavan from EG Civil Engineering College, Nagapattinam.
Hi, Vijay Raghavan.
Okay, hi, ma'am. I am studying BE Civil Engineering in EG Civil Engineering College. I know about some industrial wastewater treatment, so I will choose the NPTEL course for industrial wastewater treatment.
Okay, good. Next.
Good evening, ma'am. I am Shanmu Priya, coming from Nagapattinam, in studying Aegis Engineering College, Nagapattinam.
Okay, I think there are quite a few from Nagapattinam here. Are you all from the same college?
Yes, ma'am.
Okay, nice. Who wants to go next? Okay, Noor Jahan, I see your mic is open. Do you want to speak? Okay. Venkateshwara Rao, Naveen Kumar, and Mansi. Yeah, thank you for giving your intros and welcome to the class. Anybody else wants to give their intro? Okay, so let's start. So this will be a doubt clearing session. I'll also summarize whatever you've seen throughout the week, and this class will be from 7 to 9 p.m. on Mondays. So please do watch the lectures before coming to the class. Okay, so let's start with wastewater. Is my screen visible? Yeah. Okay, so what is wastewater? Your answers don't have to be correct. It can be the wrong answer also. We are all here to learn, so it's fine.
Wastewater is nothing but a water which is conducted.
Yeah, one at a time, please.
Wastewater is nothing but a not reusable, and it should be reused. It should be recycled, and it will contains contaminants.
Yeah, basically, it is water which has been used and which cannot be reused as such, and it will have some contaminants and unwanted things. So, what are these contaminants and unwanted things? They are nothing but impurities.
Yes.
Right. Someone else wanted to give answer. I think it was Mahesh.
Hi, Nikita. I can say wastewater is a. Okay. You shut Mahesh. Yes.
This water contains impurities and many impurities, mainly industrial as well as
There is a lot of
sewage
background
chemicals.
noise, so your voice is not clear.
Okay.
Okay. Now, wastewater contains impurities or contaminants or any waste substance, but how much of it? That is the question. Because if it is within limits, then it's fine. And by limits, I mean there are standards. So for each country, each state, there are some standards. And if it falls, if these concentration of the impurity falls within these standard limits, then it is fine. But if it exceeds the standards, then that is a problem. So wastewater is something which contains these impurities, and these impurities are in concentrations well above the limits. So if it is exceeding the limit, what happens is the quality of the wastewater becomes such that it cannot be used for anything. So in that case, it calls for treatment. So there are some different types of wastewater. Can you give some examples?
Yes, ma'am.
Yeah. What are the various types of wastewater?
Domestic wastewater, industrial wastewater.
Yeah, broadly they can be classified into domestic wastewater and industrial wastewater. So domestic wastewater can again be classified into two categories based on their color. Can you tell me what it is?
Uh, Gray color and black color.
Yeah. So what is gray water and what is black water?
Gray water
Household
is
wastewater,
basically bathrooms, laundry, and
household
kitchens,
wastewaters are known as
and
grey
black
water.
water mainly urine, toilet, sewage waste.
Yeah. So gray water includes water that is coming from bathrooms, washing machines, or washing laundry water. Um, Ashwin Kumar, can you please mute? Thank you.
Ma'am, sorry, ma'am.
It's okay. So basically, water that comes from bathrooms and laundry come under gray water, and black water includes,
Mainly urines and toilets.
yeah, from urinals, toilets, and so on. So these are the two categories of domestic wastewater. So grey water does not include the waste that is coming from toilets and urinals. Everything else, and also from kitchens. So grey water only includes that which is coming from bathrooms, laundry, etc. So um, ultimately these will be mixed. But if when it comes to like sometimes in foreign countries they are separated, and sometimes they are gray water is like treated a little differently. So yeah, apart from this there is also stormwater runoff. Now why we are including this is because usually the drain pipes that carry wastewater, they are designed for stormwater also. So they are taken together, and that is why we are also storm. We are also including this here. So you must be knowing about runoff. So what is runoff?
Stormwater is mainly rainwater running from the floor or lands.
Yeah, so runoff is basically water that does not percolate into the ground. So it will not percolate. Instead, if the surface does not allow for percolation, or the surface is covered with concrete or something, then the water will not be able to percolate on the soil. Instead, what happens is the rainwater, as it falls, will continue to flow. So that is called stormwater runoff. Okay, next we come to wastewater characteristics. So wastewater can be characterized into three categories. So can you explain about them? Can you name them at least?
In wastewater, mainly suspended particles. Then it has COD, BOD. Also, they have heavy metals, mainly industrial waters contents.
Yeah, but then what you said,
Then
COD, BOD, and suspended solids.
yes, high COD or BOD.
Yeah, so these can be classified into physical, chemical, and biological characteristics.
Okay.
So physical characteristics, they can be measured using physical methods like drying or taking weight and so on, filtration, etc. So these are all physical methods. So physical methods like filtration, drying, and weighing, all of these can be used to find out the physical characteristics. So this will include properties like solids, which includes suspended, settlable, and dissolved solids. And then color, odor, temperature. All of these are physical properties and they can be measured using physical methods. Now, chemical. So, chemical includes, Mahesh told, COD, BOD, etc., or chemical oxygen demand, and biochemical oxygen demand. And these cannot be determined using physical methods, so we have to use some chemical and analytical methods. So that is why they are called chemical properties. This also includes pH. And then we have biological characteristics. So biological characteristics will include what?
E. coli,
and
microorganism,
Yeah, microorganisms.
pathogens.
Mainly bacteria, algae, fungi, we have virus, fungi.
Why should we study them? Why is it important to know the microorganisms in water?
which is harmful to the man and animals if we consume it.
Yeah, so especially if we are looking at drinking water, it is necessary that we should supply water with which does not have any pathogenic organisms, microorganisms in it. So that is very, very important. So that is why we have biological characteristics. So these are the different characteristics of wastewater. So we look at each of them clearly. So first we look at solids or total solids. So total solids in wastewater will include 3 categories. So we'll divide them. First one is suspended. Now, what is the meaning of suspended?
Not dissolved and vertical.
Solid in the suspension mode.
Sorry, one answer, please.
Removal particles are called suspenders.
Huh?
This is not mixed in water, ma'am.
Okay, mixed in the sense? Mixed or not dissolved?
These are not dissolved, ma'am. These are not dissolved, but dispersed in the various levels of micrometers.
Yeah, these are not dissolved and they also don't settle down. They just remain floating or suspended in water. So that is why they are called suspended solids. Next is dissolved solids. So dissolved means they are completely dissolved. And then we have settlable solids. Okay, so for each of finding out the concentration of each of them, we have separate methods. So for settlable solids, we use an apparatus called Imhoff cone. So we will just allow the wastewater to settle down in a cone-shaped apparatus for some time, and then we will measure the height of solids. So that will tell us how much of solids are there. And then we have suspended and dissolved solids. And for dissolved solids, we have to, because these are dissolved, we won't be able to just filter out and separate them. So for determining the concentration of dissolved solids, we have to heat the wastewater. And we have to heat it at temperatures up to 180 degrees. So when we heat it at that temperature, what happens is all the water will evaporate and whatever solids were dissolved will be remaining. Now, before we have to heat up, what we have to do is, because if we take first, if we separate out the settlable solids and we only take the remaining, then it will have both suspended and dissolved. So first we have to separate suspended and dissolved, and for that we have to pass the water through filtration or a filter paper. So this filter paper's weight needs to be taken before filtration, and it needs to be weighed again after filtration, because after filtration whatever suspended solids will be there, it will come into the filter paper. So now if you weigh the filter paper after filtration, it will have the weight of filter paper plus the weight of suspended solids. And if you subtract the empty weight of filter paper, that will give you how much weight of suspended solids are there. Now, this is for suspended solids, but you still have to measure dissolved solids. And for that, you have to take the water that has been filtered through, which has passed through the filter. So this water will be collected separately, and then that will be heated at 180 degrees Celsius. Now, when we heat this water, all the water will get evaporated, and whatever dissolved solids are there, that will be retained on the container. Now, for this also, you have to weigh the container before putting the water, and then after you have heated it, so that the difference will tell you how much of solids have settled. How much of solids are remaining after evaporation. Is this clear?
Yes, ma'am.
Okay, so basically these are all physical methods. First, we have to settle the solids. We have to allow the solids to settle to determine how much settleable solids are there. And then to find out suspended and dissolved solids, we have to pass the wastewater through filter paper. So the weight of solids remaining on the filter paper will tell us how much of suspended solids are there. And then whatever water has been filtered by the paper, that will be collected and heated at 180 degrees Celsius. And what happens then is water will evaporate, and whatever dissolved solids are there, they will be remaining on the container. So if we get the weight of that solids after evaporation, so that is nothing but the dissolved solids, right? So that is how we calculate it. Okay, and then coming to chemical properties. So chemical properties include pH, dissolved oxygen, biochemical oxygen demand, and chemical oxygen demand. So before we start, what is pH?
Negative logarithm of hydrogen ion concentration.
Yeah. So minus log to the base 10 of H plus ion concentration. So that is pH. And what is BOD?
Biological oxygen demand, which requires how much oxygen required for converting, required by organism, microorganisms present in the wastewater to convert the contaminants
Into
harmless. It does not mean harmless. Conversions of toxic compounds converted required toxic compounds which is with the help of microorganisms is converted to harmless by the oxygen oxidation process.
Okay, so BOD is nothing but the biochemical oxygen demand. And what this means is generally for in wastewater, we go for biological treatment process. And when we go for biological treatment process, the main thing which is responsible for the treatment is bacteria or microorganisms. So these microorganisms need oxygen for survival. So, and if we give them oxygen, they will use that oxygen and they will break down the organic substances or substrates into simpler compounds like carbon dioxide, water, and so on. So, in order for them to break down these organic matter, this organic matter is nothing but food for the microorganisms. So, they will eat this. Basically, they'll break down this organic matter, and they will take the energy from that, and they will continue to grow and multiply. So their population will increase, and again more bacteria will be there, and that bacteria will also continue to degrade the organic matter. So does anyone want to say something? Okay, so that's what happens, and for that to happen, the bacteria or microorganisms need oxygen. Okay, so the amount of oxygen required by the bacteria to break down the organic matter is called your biochemical oxygen demand. Because there's a demand by the microorganisms for oxygen, right? So that's why. And bio because we use microorganisms. And then we have COD. What is COD?
Chemical oxygen demand.
Bio-oxygen demand.
Chemical oxygen demand.
Yeah, chemical oxygen demand. So what is chemical oxygen demand?
Like BOD, like the same COD, the chemical providing oxygen to convert a harmful toxic substance to harmless compounds. For example, if we ammonia containing compound, we provide more oxygen, it converted to a harmless nitrate. Ammonia is toxic and nitrate is harmless.
Okay, so what is the basic difference between BOD and COD?
Basic difference is biological oxygen demand is carried out by microorganisms. Microorganisms takes oxygen and converts the chemical components, I mean pollutants, into a harmless. In case of in case of COD, we provide oxygen required for a conversion of toxic compounds to a harmless compounds. It means free radical chemical will be provided, I mean available generally. So if we provide oxygen, it turns to a harmless forms. I think the free radical chemicals are more toxic than ionic compounds. So for this conversion, we need to support oxygen.
Actually, free radicals are not
It
involved.
it is it is the oxygen demand for non-biodegradable and inorganic compounds.
Uh, in COD,
Biodegradable, sure. So chemical, Shilpi Ranjan, yeah. Shilpi Ranjan, do you want to say something or can you please mute?
Madam, in COD, basically we measured biodegradable and non-biodegradable matters, and in
Yes.
BOD we measure only organic matters.
Yeah. And in the major difference between biochemical oxygen demand and chemical oxygen demand is that the what is that? The agent which is carrying out the reaction in BOD is mainly bacteria. But chemical oxygen demand is for chemical oxygen demand, we measure how much oxygen is required by chemicals. Now, see, reaction is the same. You are going to oxidize the organic matter into simpler compounds. But the way it is done is different in both. In BOD, it is done, we measure how much oxygen is consumed by the bacteria. Whereas COD measures how much oxygen is required by the chemicals for oxidizing. Both are going to be the same, both are going to be oxidation of organic matter, but bacteria can only degrade one which is biodegradable. That is, there is a limit. So bacteria cannot degrade all kinds of organic matter. So there is only I mean it can only degrade one things which are biodegradable. But COD will measure how much oxygen is required for chemically degrading I mean, all kind of organics. So it can be biodegradable as well as non-biodegradable. So that is measured in COD. So basically, we give some chemicals and then we measure how much oxygen is used up before and after the reaction. So that will the difference will tell us how much of oxygen will be required. So the agent here is chemicals and here it is bacteria. So that is the basic difference. Is that clear? Okay, and then yeah, someone has raised a hand. Ashwin Kumar, do you have a question?
I'm sorry, it's just by mistake. Just to take a note, I was just raised a hand.
Okay. So now we know what is BOD and what is COD. So there's a ratio of BOD to COD. Okay. And generally, this is important to find out what kind of treatment to give. So, if your BOD to COD ratio for the wastewater is higher than 0.5, which means your COD is almost 2 times of BOD, then what it means is the wastewater contains more non-biodegradable organics. It contains more non-biodegradable organics than biodegradable organics. So what can we conclude from this?
Anaerobic treatment.
No. So if your wastewater contains more non-biodegradable organics than biodegradable organics, is it a good idea to go for biological treatment?
No.
Yeah. Because it won't be feasible because your BOD or the biochemical oxygen demand is very less. So that is why in that case, it is better to go for if your COD is very high, then your BOD, it is better not to go for biological treatment. But in case, if it is like this, in case if it is the other way, your BOD is higher than COD, then it is better to go for biochemical or biological treatment. Is this clear? Okay, coming to nitrogen content. So nitrogen is present in which forms?
Ammonia, nitrite, nitrate, NH2, NH3, NO2, NO3.
Yeah, ammoniacal nitrogen, then nitrite and nitrate. So in fresh wastewater, it will mostly be present as proteins or albumin nitrogen. And then from there, it will get converted to ammonia slowly as biochemical degradation happens, as the bacteria starts degrading. First, proteins will be converted to ammonia, and then ammonia will get converted to nitrite and then nitrate. And then sulfur content. So sulfur is present in which forms?
Sulfate, H2S, SO2, SO3.
And organic sulfur. And then we also have phosphorus content. So phosphorus content is mainly as phosphate. And depending on the pH, it can exist in different forms. So at neutral or pH 7, it can exist as H3PO4. And this this form will be there up to pH 4.7. So as soon as it goes to pH 4.7, it will this H3PO4 will no longer exist. Instead, it will exist as H2PO4. And when it goes beyond 9.8 at alkaline pH, if it goes beyond 9.8 or at 9.8, it will exist as HPO4. And at highly alkaline pH or at pH 13, it will exist just as phosphate ion. And then we also have heavy metals. So can someone explain what are heavy metals? What are heavy metals?
Nickel, zinc, chromium, and other lead, tin. Those are the heavy metals.
Madam, high atomic weight and density.
Yeah, density should be how much to be classified as heavy metal?
Greater than water.
Yeah, so heavy for being called a heavy metal, the density of the metal should be more than 5 times of water. Only then it will be called as heavy metal. So yeah, some examples of heavy metal are lead, chromium, mercury, and so on. And what these are, why they are dangerous is because they are known to cause diseases like cancer. They are carcinogenic and they are also known to cause genotoxicity. So, what genotoxicity means is these heavy metals they can alter the genes and they can mutate the genes and they can cause genetic diseases in the upcoming generation. It can cause like disabilities or chromosomal defects and so on. So all of these are come under genotoxicity. So that's why it is important to remove heavy metals from wastewater and drinking water. So these heavy metals can cause cancer and genotoxicity at very low concentrations also. So even if we drink a very low concentration of water containing heavy metals, with time it can accumulate in our body. And this process is called bioaccumulation. So over time, they can accumulate in our body and they can get stored in fat cells or tissues, and they will just remain there. So and it will take a very very long time for them to leave our body. And while they are inside the body, they create all these diseases like cancer or genetic mutation and so on. So that is why it is very important to avoid these kind of chemicals. Okay, now we are coming to biological characteristics. So like we've seen before, this includes bacteria, viruses, protozoa, even worms, and so on. So all of these should not be present in water, especially in drinking water. And protozoa and worms are easy to identify. With naked eye, we can see worms and sometimes even eggs. So they can be removed. But bacteria and viruses, they are not seen by the naked eye. And therefore, we need specific tests for determining their presence and their concentration. So we won't be able to detect all kinds of bacteria. That is almost impossible because there are new bacteria which are evolving and coming up. Same goes for viruses. So it is not possible to detect and measure each one of them. So instead, what we do is we only focus on bacteria which can cause diseases. So they are also called as pathogens. So pathogens are bacteria which cause diseases. So mainly it includes communicable diseases, and there is one particular bacteria called Escherichia coli or E. coli. So this bacteria is a representative or indicator of pathogenic bacteria. So what this means is if E. coli is present or E. coli is detected, it means that there could be other pathogenic bacteria also. Because E. coli is basically bacteria which is found in human fecal matter. So if that is present in water, it means there is some kind of contamination. So if E. coli is present, then we assume that there are other pathogenic bacteria also present in that water. So that is why we detect E. coli. Okay, so now I told you about in the beginning. I told you about some limits or standards. So in India, we follow IS 2490. So this gives the discharge standards. For effluents. So effluents are nothing but industrial discharges or wastewater that is discharged from industries. So before discharging these wastewater, the industries should ensure that the properties of the wastewater that they are discharging should conform with what standards are given in IS 2490. So it will have a particular set of properties like dissolved solids, suspended solids, BOD, COD, DO, all of these. So before discharging into the open, and also for each kind of discharge, like whether it is going to be dumping into rivers or just dumping into open land. So for all these kinds of different discharges, there are different kinds of discharge standards. So if it is going to be, yeah, you can find it online. So if you're not able to find it, then let me know. So yeah, so there are different kinds of discharge standards for the type of disposal. So if the industry is going to dispose the wastewater on land, then it will have a different set of regulations than what is then what will be the regulations for discharging into water bodies. So for water bodies, the discharge standards will be slightly more stricter and than for land disposal. Okay, now coming to managing industrial wastewater. So the first step in managing wastewater is to reduce. So if we can reduce the wastewater generation as much as we can, then there is nothing better than that, because if we produce more wastewater, then we need to treat that wastewater. So for that, we need to invest in resources, and we also need to use energy for treatment. So all that is just extra cost and energy wastage. So the first and foremost step is to ensure that we reduce the amount of effluent generated. So that is the first step. We can have maybe advanced processes which do not require the use of a lot of water. So all this can be done to reduce the amount of wastewater that is generated. The second step, once we have generated the wastewater, the next one is to recover as much as possible. So before sending the wastewater for disposal, if it was possible to separate it or recover it from if it was possible to separate only the water from the wastewater, and then we can recycle it or reuse it for the other purposes, then that is a better idea than to just dispose the entire thing. And the third one is to recycle. So these days we have terms like zero liquid discharge. So can you tell me what this means? What is ZLD or zero liquid discharge?
In ZLD, mainly three steps, mainly ETP, then RO, and ME. In ETP, we treated the water. In RO, we the mainly dissolved solids. They treat the dissolved solids, and ME. The in RO there is undis- uh, they treat in ME.
But why we need zero liquid discharge, or what is the idea behind zero liquid discharge?
To utilize the process water, to use the process water in flushing or cooling tower or firefighting mainly.
Yeah, those are the ways in which we can use, but mainly zero liquid discharge means, so the zero liquid means that we should not generate any liquid waste as
Uh,
much. We just
leaving no effluent to be discharged into the environment.
exactly. So that is zero liquid discharge, which means we don't discharge only 0% of the liquid waste that we are generating. So whatever liquid waste is generated, it must be reused and recycled within the industrial plant itself. So that can be done in a number of ways, as suggested by Mahesh, I think. So that can be done in a number of ways. So we can reuse it for gardening. We can reuse the coolant water, and so on. So we can even use it for flushing. So there are so many ways in which we can do that. So that is the aim of zero liquid discharge, and these days it has become a norm for every industry to follow, so that the liquid waste generation is completely minimized. So that concept aligns with this: reduce, recover, and recycle. So reduce the amount of waste that is generated, and once generated, try to recover it as much as possible, and try to recycle the wastewater into different ways like gardening, flushing, and so on, so that we will achieve the zero liquid discharge. Okay, so coming into detail about reduce. So reduce mainly means like reduction in the volume of wastewater that is generated. And once generated, the volume reduction can be done. Uh, so for volume reduction, the first step is to separate the wastewater. So if you have like a treatment plant which is operating for both domestic and industrial, then it is important that we separate domestic and industrial wastewater. And we also need to ensure that there are no leaks, because if there are leaks, then the wastewater is going somewhere else untreated. And we also have to separate the storm runoff. So common pipes for stormwater and wastewater were the norm in some few decades back, because there used to be off seasons and off timings when people did not use or did not discharge a lot of wastewater from their homes. So in those cases, like if it is in those cases, it was feasible to mix stormwater and rain domestic water. But in areas which are heavily densely populated, it will not be a feasible idea anymore, because we need better pipelines, and we need separate pipelines for stormwater as well as domestic wastewater because of the high population and high discharge. So the first step towards treatment is equalization, and we have a device called equalization tank. Okay, so how many of you have been to a wastewater treatment plant? Has any one of you visited a wastewater treatment plant?
Yes, Nikita.
Yeah. So, what is the first device or the first treatment unit that you will get to see in a wastewater treatment plant?
In terms of treatment, you are correct. There is equalization tank, but practically before equalization tank, we generally have the screening unit for screening out the physical impurities like uh, big particle size or something. So
Yeah. So I was asking about that.
after screening, there is a equalization tank.
Yeah. So equalization tank is one of the first treatment units. So of course, before that, you have the screening facility to remove all the floating particles. But once it passes through that, it will go to an equalization tank. And what does it do basically?
In equalization tank, main purpose is to mix properly so that it temperature, and then if COD is less, and some part of COD is greater, then it is mixed properly, and uniformity is the main purpose for the neutralization tank. And also in neutralization tank, we neutral the pH mainly 6 to 8. It is the main purpose of neutralization tank.
Okay, so that is one of the purposes of equalization tank, to maintain uniformity in the properties, uniform properties. But there is also a second and more important reason for constructing an equalization tank. So can someone explain what it is?
Equalization tank helps to avoid the shock loads actually
Yeah,
by equalizing the parameters.
parameters. What
Like
parameters?
uh, see, there is flow out in and out, so uh, we provide a good retention time for equalization tank. It is a huge capacity tank, so all the parameters here equalize so that uh, after that equalization we do like we may have physiochemical treatment or biological treatment. So for that uh, uh, those tanks will not face the shock loads. So
So again, yeah, that's the same as the first point, that you are saying that the properties or parameters should be uniform. But the main reason why
there may be
is so that we have
there is one benefit of settle. It reduces the settleable solids also.
yeah, but
Ma'am, I also add one point. In mainly equalization tank, there may be a diffuser, and due to diffuser or air, the volatile substance or volatile material may be reduced.
yeah, equalization tanks are responsible for reducing BOD by maybe 10% to 20%. But yeah, we are not looking at that. No, we are focusing more on uniformity of flow and uniform properties or parameters. So what equalization tank will do basically is if there are maybe off timings or off seasons. So for example, people use water a lot in the mornings and evenings, but there won't be much wastewater generated in the afternoon time. So and a wastewater treatment plant is designed for continuous flow. So then what happens is the equalization tank will store the excess wastewater that is generated in mornings and evenings, and that will be supplied in the afternoons when the flow is very less. So that is the main reason for having an equalization tank, so that the flow is uniform throughout the day. So since they are designed for 24 by 7 operation, we cannot have, we cannot stop the equipment in between, because that will again have repercussions in the treatment process, because bacteria need food and oxygen for survival. So we cannot deny them that. Otherwise, there will be some imbalance and that will create further problems. So we do not want to create that situation. So that is why it is important to have uniform flow. And that is where equalization tanks come into the picture. And they also, because they are equalization tanks and they have, they are built for retaining the liquids for a longer time. They also serve as settling tanks where they remove some of the settleable organics inside them. And they also ensure that water coming from different sources are mixed together and that the properties become more uniform. For example, like water that is coming from a butcher's shop will be high in proteins and it will have a lot of nitrogen containing waste, nitrogen containing organics. So that will be very different from that coming from maybe other sources, or sometimes if it is raining heavily, then the wastewater will be highly dilute. So all of these are conditions which need more uniformity. So that is where equalization tanks come. So they are built for maintaining a uniform flow rate and also for uniform parameters. Is that clear? So equalization of flow and equalization of strength. Strength, by strength I mean the concentration. So that is the reason for having an equalization tank. Okay, so for designing an equalization tank, the first thing that we need to know is the mass loading rate. Or MI. So mass loading rate is nothing but the product of flow rate, or QI. I denotes the time. So flow at a particular time I multiplied by the concentration at a particular time I. So this will give you the mass at a particular time I. So QI.
Excuse me, ma'am. Can you repeat again this statement? This statement.
Which statement?
Ma'am, mass loading rate from the statement, ma'am.
Yes. Mass loading rate is the product of flow rate multiplied by the concentration. So units of flow will be what?
Liters per minute, or gallons per minute, or ton, meter cube per hour, something like that, ma'am.
And concentration?
In ppms, ma'am, mostly.
ppm can also be converted into grams per meter cube. So
okay.
Yeah, so meter cube will get cancelled from both sides, and then we are left with gram per hour.
Okay.
So this will give us the mass rate, or the rate of flow of mass per unit time. So that is the mass loading rate. And that is a product of your concentration with flow rate. So QI is the flow at a particular time I, and CI is the concentration at time I. So if we multiply them, and we will be ending up with the mass at a particular time I. These two will be giving the mass. And then we have the weighted average concentration. Ashwin Kumar, can you please mute yourself? Thank you.
I'm sorry, ma'am.
So the weighted average concentration is given as now this is ranging from I equals 1 to n. So the time is ranging from 1 to n. And here also the concentration is 1 to n. So this is the average concentration over a given period of time from from t equals to 1 second to t equals to n seconds. So if we want to find the average concentration, then we have to multiply the concentration for each second with the flow rate for that second and divide it by the flow rate for that second. So this will tell us, and we can do it for different times, maybe at 1 minute, at 2 minutes, and then 3 minutes, and so on. So for each of these times, we have to multiply the concentration with the flow rate and divide it by the flow rate. So and then I'll just give you an example. So at t equals to 1, so it will be C1 Q1 by Q1. Now, if we want to find the weighted average concentration and we want to do it from t equals to 1 to t equals to 10, then we have to add C1 Q1 by Q1, C2 Q2 by Q2, and etc. Do it till C10 Q10 by Q10. So adding all this will give you the total weighted average concentration. Oh, 1 second. So if we have to find the weighted average concentration from 1 to 10, then we have to multiply C1 Q1 plus C2 Q2 plus C3 Q3 and so on till C10 Q10, and we have to divide it by Q1 plus Q2 plus until Q10. So this will give you the weighted average. Then we have the peak mass loading. So the peak mass loading is the maximum value of mass or MI at a particular time over a 24-hour period. So what this means is over a period of 24 hours, the maximum value of mass. So MI means, I denotes the time. So what this means is over a 24-hour period time, at one particular instant, at one particular time, the the value of the mass will be the highest. So over a 24-hour period of time, we can have, if we measure the mass at every minute, so at one particular minute, the mass will be the highest compared to the other, the mass at other times. So that maximum value of mass is peak mass loading. And similar to peak mass loading, we also have the minimum mass loading rate. So this is the lowest value of MI. over a 24-hour period. Okay, so these are some of the parameters that we need to calculate for designing an equalization tank. I'm not going to the details of the design, so it is already available in the lectures, so you can go through them. And then we have two types of equalization tank. So can you explain what they are?
Graphical analytical.
Sorry?
Graphical analytical.
Yeah. Those are the types of, I mean, you are talking about the design, but I'm asking what are the two types of equalization tank generally seen in wastewater treatment plants?
Square type and rectangular type.
No, I'm not talking about shapes here.
It may be flow equalization and strength, like load equalization.
No. So I'm asking about the placement of the equalization tank in the treatment plant.
Online, offline.
Yeah, inline and offline. So what do these terms mean? Inline equalization tank and offline equalization tank?
Offline will be separately used.
Yes.
Separate tank, which is away from the influent to the thing.
Yeah.
And the inline requires pumping machinery.
Okay. So you said offline is separate. So what is the purpose then?
So whenever there is fluctuation of load, it gets stocked there.
Yes. So that is for storing the excess. So there are two types of equalization tank generally in wastewater treatment plants. The first one is the inline tank and the next one is offline tank. So inline tank is it is in line with the treatment process. That is like it is connected with the next treatment unit. So whatever wastewater is coming to the treatment plant, it will be taken directly to the inline tank, and then there it will be the flow and the concentration, everything will be equalized, and the entire flow will be mixed together. So that is the main thing about inline equalization tank. And because we are mixing the entire flow that is coming, it requires more pumping. And more pumping means more electricity and more cost. But an offline tank is like a storage unit. So only if there is excess water or excess wastewater that is entering the treatment plant, only that excess will be taken to the offline equalization tank for storage. And once later on when the stored water is required, that will be taken and that will be treated. So this requires little less pumping because we are not mixing the entire flow. We are just storing separately, and then that is going to be treated later. So this requires less pumping. Okay, and then neutralization. What is neutralization?
Bringing down the concentration levels.
No, we are talking in terms of pH here. So neutralization means to ensure that the pH of the wastewater is neutral or around 7. So this is done before discharging the wastewater to the disposal. Before disposing the wastewater. So once the wastewater is generated, once the treatment process is done, we want to ensure that it is not highly acidic or highly alkaline. So we have to neutralize the wastewater before discharging. Especially, this has to be done if we are discharging into water bodies, because aquatic organisms are highly sensitive to pH. So this can be done if it is highly acidic, we can add limestone. So limestone will react with acids like H2SO4 if it is present in the wastewater, and then it will produce calcium sulfate and H2CO3. But the disadvantage of this process is that CaSO4 can cause hardness. This is also causing hardness, but this is temporary hardness and this is permanent hardness. So this increases the TDS and hardness levels, this process, that is using limestone. The second one is using caustic soda. So caustic soda is Na2CO3, and if this reacts with H2SO4, it will produce sodium sulfate, which is not causing any hardness. Yeah, these are two different two processes which can be done for neutralization, especially if the wastewater is highly acidic. And then other processes like using flue gas. What is flue gas?
Water boiler flue gas, ma'am.
Yeah, any kind of flue gas in general. What does it mean actually?
Carbon dioxide.
It is a component of flue gas, but my question is, what is flue gas?
In flue gases, the pH is mainly acidic. We can use that flue gases for the alkaline type effluent.
Yeah. So flue gas is generally gaseous waste that is coming out of an industry or an or a plant, especially if we go for coal plants or thermal energy plants, then there we can have a lot of flue gas. So flue gas generally contains CO2, and when CO2 dissolves in water, it gives carbonic acid, and this carbonic acid can be used for neutralization. And in some cases, if CO2 can be directly separated, then that can also be used for the purpose. Then next we will talk about proportioning. So proportioning is nothing but maintaining a proper carbon to nitrogen to phosphorus ratio. So why is this ratio important?
Again, to check what type of treatment.
Yeah. Any other answers?
Better growth of microorganism.
Okay. So like I said before, organic matter generally have carbon, nitrogen, phosphorus, sulfur, hydrogen, and oxygen. So all of these are present in different ratios. So the the main thing is carbon, nitrogen, and phosphorus. So if these are in a proper ratio, then the organics will be easily taken up by the bacteria for their growth. But if the ratio is not good, if there is any imbalance, then the growth of bacteria will be slowed down. Because ultimately, what we want is for the bacteria to break down the organics and use it for their growth and multiplication. So, if we don't provide them with adequate nutrients, then it will be highly, uh, it won't be good for the process. So bacteria will want this ratio to be maintained in a certain way so that their cells can use the nutrients appropriately. So if there is any imbalance, then their growth will be hampered. So that is why we have to maintain a proper ratio of carbon to nitrogen to phosphorus. So for an aerobic system, so again, what is a aerobic system?
Oxidation process
Hmm?
where microorganisms you consumes oxygen, or we provide oxygen for conversion of chemicals. Chemicals means pollutants to a harmless forms, which is readily disposable to water streams or in open lands or some other things.
Basically, the microbial degradation which takes place in the presence of oxygen and the bacteria which take up the oxygen are called aerobic bacteria, and those that do not take up the dissolved oxygen are called anaerobic. So, in either way, the degradation happens. So, for the aerobic system, the ratio of carbon to nitrogen to phosphorus should be 100 is to 5 is to 1. And for anaerobic, the ratio should be 300 is to 5 is to 1. So because they are different types of, there are two different types of bacteria, aerobic and anaerobic. That is why we see a difference in their nutrient requirements also. So this should tell you how sensitive the bacteria are in terms of how sensitive the bacteria are if there is any change in the nutrient profile, or if there is any change in the type of substrate that they get. So if they are going to get a slightly different feed or substrate, then it means the bacteria will also change accordingly. So um, the bacteria will that required, that used to survive will not be able to survive if the substrate is different. Instead, it will evolve and a new kind of bacteria will develop, which will be able to degrade the new substrate or new feed or new organic matter. So that is how they evolve and they proliferate. Okay, so the rest of the lectures are about designing an equalization tank, and I'm sure all of you will be able to go and see the lectures. And if you want, you can even practice them. So I'm not going to go into those details for now. So, any other questions?
Ma'am, can you hear me?
Yeah.
Ma'am, I'm sorry, ma'am. I didn't get I'm not able to refer the whole the lecture video, ma'am. So where I could get that video, ma'am?
Have you logged into NPTEL website?
You wanted me to. I'm sorry, ma'am. I don't know currently what's the procedure or where to follow it. So can you guide me where to find and read listen the video lecture video, ma'am?
So you can log into this nptel.ac.in, and it requires a sign up. So you can give your email ID and register on it, and then you can select the course. And then I think you should be able to view the videos.
Oh, okay, ma'am. Thank you.
Yeah. Any questions from today's class?
Hello.
Okay. If you want,
Hello.
yeah.
Yeah. Ma'am, I want, there is one query. I want to ask is that the last week videos, they are available online. So, like, how it is going to process our class, ma'am? Like, it will be daily or weekly, you will be uploading the lectures online, and then we will refer from there and send you the assignments. So, like, please can you brief the procedure, ma'am?
Yeah. So you have registered for the course Industrial Wastewater Treatment, right? It is a 12-week course, and each week will have 5 video lectures. So, and all of these lecture videos are pre-recorded, so you can watch those lectures whenever you want. And on Mondays from 7 to 9 p.m., I'm the TA, I'm the teaching assistant for the course. So you can ask me any questions you have after watching those lecture videos.
Okay.
So that is the purpose behind this interaction session. So that if you have any questions after watching the videos, you can ask me and I'll be able to clear it. And I can also give you a summary of the week's lectures during this time.
Okay. Okay. And submission of assignments, how it would be, ma'am? Like,
You have to register for the course and then you can log into NPTEL website and then there you can submit the assignments.
okay. Okay. Sure. Yes. Yes. Thank you.
No problem. Any other questions?
Ma'am, can you explain the examples of graphical and analytical methods?
Like I said, you can refer to the lecture videos for the design process, but like if you want from the next week, we can solve some example problems.
Okay, thank you, ma'am.
Any other questions?
Ma'am, for exams, is it only multiple choice questions or description also?
I'm not sure. Actually, I am not responsible for the exam and corrections. So I'll be here for the live session. So as long as the course runs, I'll be there. So once the course is over, like it will be handled by another set of teaching assistants, and like the process will be different. So my job is to clear the doubts that you have in after watching the lectures.
Thank you.
No problem. Any other questions or queries? Okay, so if there are no more queries, we will be closing this session. Okay, thank you all for joining. See you next Monday. Bye.
Thank you, ma'am. Thank you.
Okay, ma'am.
Thank you. Thank you.